Geology has 5 basic principles that lay the foundations for all other observations and interpretations of rock formations and the features within. These have been observed, proposed, and built upon by geologists over the centuries and are an important part of modern-day geology. These principles are Uniformitarianism, original horizontality, superposition, cross-cutting relationships, and Walther's law. So let's have a quick look at each. Uniformitarianism, say that 5 times fast, is the idea that the processes we see at work in the environment today are the same processes that were at work in past environments. So things like weathering, erosion, tectonic activity, depositional environments, climate, volcanic activity, and much more have been ongoing processes for most of Earth's history and have shaped and destroyed past environments, modern environments, and will affect future environments. So we know volcanic activity produces igneous rocks. Where we see igneous rocks today, we can assume that at some point there was volcanic activity at work in the area. We can see sand being deposited along beaches and riverbanks and infer and even look for signs of sandstone having been deposited in these environments. We see marine organisms living their best lives in different parts of the seas and oceans. So when we see burrows and fossils of marine creatures, we know that this would have once been an active marine environment of some kind. From looking at the surrounding rocks, it's even possible to gauge how deep underwater these organisms lived purely from looking at where we see similar sediments and organisms today. The phrase often quoted is, "The present is the key to the past." Original horizontality relates to sediments in most depositional environments. The idea is that sediments will be deposited as horizontal or near horizontal layers, and any tilting of these layers is usually the result of tectonic activity. So this mudstone would have started out life horizontal, but has since been tilted. These layers have been folded all over the place. So of these ones, here's some more tilting, here's some more folding. All of these would have started out horizontal and have since been altered. Superposition is the idea that in a rock sequence, the oldest rocks will be at the bottom and the youngest will be at the top. This is usually an easy one to work with, but there are features like overturned folds and even erosion that can get you scratching your head a little bit. If you're lucky, there are features in some rocks that can help you determine the depositional sequence, but you gotta find them first. Cross-cutting relationships is the idea that a rock formation had to be present first for it to be affected by folding, faulting, igneous intrusion, and erosion. So in the sequence of events, it would be deposition, folding, lithification, and then faulting, intrusions, or erosion. Essentially, these features will always be younger than the rock that they are found in. Here's a few examples of faulting. Here's a few examples of igneous intrusions. Walther's law states that depositional environments that occur laterally adjacent to each other today would have occurred like this in the past and should be evident in the rocks and sediments. So if we take a beach to an ocean environment, at this end you would expect to see sand, and at this end you would expect to see finer material like silt and clay, and in the middle, likely a mix of the two to varying degrees. If we see a sequence like this present in a rock formation, we can infer that the likely environment the rocks were formed in would have been a beach to an ocean environment. If sea level were to rise or fall, this would also be reflected in the rock sequence. Now, if part of a sequence is missing, this will likely be due to erosion. Now, like all rules, there will always be exceptions, and real life will usually be more complicated than how I've presented this information, but these are still good foundations to keep in mind when examining rock formations.